Hello everyone. So in this video we will be solving assignment 12. Okay. So instead of making two assignments, I have made only one assignment, and in this assignment there will be a lot of question actually. So this is the first question. This is the second question. You can take the screenshot or pause the video and solve it. Third one. Fourth. Fifth. This one is the sixth. Seventh. Eighth. Ninth. 10th. 11th. 12th. Yeah. So there are 12 questions. Okay. So we will be solving one by one. In this question, what you need to do, you need to find I at 0 plus. Okay. So you should be able to solve these kind of questions. I at 0 plus you are asked to find. So for t less than 0, what is happening? For t less than 0, this switch is off. That means steady state would have been reached. For at t equals to 0 minus, steady state would have been reached. At t equals to 0 minus, because this is 6-volt battery which is there from t equals to minus infinity. So steady state would have been reached. Right. So if let's just call this current as IL and this current as VC. So tell me what will be the value of IL? IL at 0 minus. Tell me. And the same value will be IL at 0 plus. In case of inductor, we are interested in the current because current is conserved here. Okay. So 6 by 2, that means 3 ampere. Right. And what about VC at 0 minus equals to at VC at 0 plus? What about VC? VC would be 1 by 2 into 6, that means 3 volt. Are you getting my point? At steady state, this will be shorted, this will be open circuited. So in short, this will be the current. So that would be 3 ampere. And since this is open circuited, there will be no voltage drop across it. So whatever the voltage drop is there across this resistance, the same voltage drop will be there across the capacitance. So that voltage drop is 3 volt. So now we can make the circuit for t greater than 0. Circuit for t greater than 0. Okay, you will not have to make the circuit if you are very good with the network analysis, and till now you must have been very good with the network analysis because we have solved a lot of questions. But since I am explaining, I will make the circuit. So that, otherwise you can directly solve by looking at the circuit as well, right? 1 ohm, 1 ohm, and here we are having for not for t greater than 0. I am making at t equals to 0 plus because this is what we need at t equals to 0 plus. 3 ampere current, and there we have 3 volt. Here I am having 3 ampere current, then this is shorted because the switch is closed. The switch is closed. Here I am having 3 volt. Here I am having 3 volt, and then I am having a resistance of 1 ohm here. Now I need this current, right? I of 0 plus. So tell me, how do I find it? This 3 volt is coming on this 1 ohm resistance. So how much current is going downward? That is 3 ampere. So 3 ampere current here, 3 ampere current here. So what is I of 0 plus? That is 0 ampere. That's your answer. Right? What did we do? First we found the condition. In the condition, capacitor is having 3 volt, inductor is having 2 ampere current. Sorry, 3 ampere current. So if it is having 3 ampere current, here I have 3 volt. The same 3 volt is applied across the 1 ohm resistance. So 3 ampere current here, 3 ampere current downward. So there 0 ampere current is going. So that's why my answer is 0 ampere. Okay, well and good. Let's see this question. We have to find I of 0 plus. Okay, so for t less than 0, steady state would have been reached. So at t equals to 0 minus, steady state would have been reached, right? Steady state, I will put steady state would have been reached. So what will be the, let's just call this as VC. Okay, this as VC and this as IL. So tell me what will be the VC 0 minus? Open circuited, shorted. So whatever the drop across 5 kilo ohm resistance, that will be the same drop across VC. This will be shorted, so this will be the condition. 4 plus 1, that means 5 kilo ohm, and this is shorted, and this is my VC. So VC will simply be 5 volt, right? 5 kilo ohm and 5 kilo ohm. Between 5 kilo ohm and 5 kilo ohm, 10 volt will be divided, so it will be 5 volt. What about IL 0 minus? This is open circuited, and this switch is open. This switch is open. and capacitor is open circuit and the inductor is shorted. So what will be the current? 10 upon 5 plus 4 plus 1. That means 1 milliampere current, right? So in the circuit we are having 1 milliampere current. What will happen at t equals to 0 plus? Voltage and all these things will be conserved. So here I am having 10 volt, right? Here I am having 5 kilo ohm resistance. This capacitor will be replaced with a battery of 5 volt. I am having a 4 kilo ohm resistance. This will be grounded, right? This will be grounded, right? Here I have 1 kilo ohm resistance and the current source is of 1 milliampere, right? So if this is grounded, this is also grounded. So here I am having 0 potential, here I am having 5 volt. So what is the current here? 5 by 4, that means 1.25 ampere, right? Now what is the current here? 10 minus 5 by 1, that means 1 milliampere. Now you need to find this current. So what will be this current? This current would be 1 milliampere current is coming from here and 1.25 is going here. That means 0.25 will be going upward. So IC at 0 plus would be minus 0.25 ampere, milliampere actually. All this is milliampere. 1.25 milliampere. So IC of 0 plus would be minus 0.25 milliampere, right? Got my point? What did we do? First we found the condition at t equals to 0 minus, it was having 1 milliampere current, it was having 5 volt. So 10 minus 5, 5 by 5, 1 milliampere current going that way, and 5 by 4, that means 1.25 milliampere current going that way. So 1 is coming here, 1.25 is going there. That means 0.25 would be coming to upside. Okay, so 0.25 would be coming upward. So current is minus 0.25 milliampere because the given direction is downward. Okay, let's see this question. We have to find the V0 value at steady state. So tell me one thing, will there be any current in this capacitor? Anytime there will be no current in this capacitor. Why so? Because this is an open circuited, right? Let's assume this is my circuit, this is some circuit, this, and there is some applied voltage, and this is I am calling V0. This is an open end. If this is an open end, there will be no current, right? What I am saying is that let's just understand it with the network, resistor network. So I have a 10 volt battery, 5 ohm resistance is there, 10 volt, 5 ohm, and I make this 5 ohm and I call this as V0. Will there be any current? No, because this is open ended, right? So 1 volt will remain there as it is. This 1 volt will remain there as it is. As it is. No current, no charging, no discharging. 1 volt will be there as it is. Now, let's just call this potential as V dash. Now tell me what will be the value of V dash at steady state? V dash at steady state. Tell me what will be the value? Initial voltage, that is 1 volt. That it will conserve. Now, what is the initial voltage in the circuit? 2 minus 2 minus 1. That is 2 minus 2 minus 1. It will be divided in inverse proportion C and C, between C and C. Because this capacitor C is out of action. This capacitor C is out of action. Only the voltage will be divided between this C and this C. Because this is open circuit, so that is out of action. So the voltage will be simply divided between this C and this C, 1 by 2. So simply it will become 0.5 volt. Okay, 0.5 volt. And what is V0? V0 is V dash minus 1. That means it will be minus 0.5 volt. So this is my answer. And steady state would be reached immediately because there is no resistance involved. So everything will be immediately, right? So 2 minus 2 minus 1 will be divided between two capacitors. This concept I have already taught you in switch capacitor, right? How to write the potential. Initial potential, then just see the complete potential in the circuit. The complete potential in the circuit is 2 minus 2 minus 1, that is minus 1. Minus 1 will be divided between two capacitors, C and C. So minus 1 into 1 by 2. So basically 0.5 volt. Now here I am having 0.5 volt and this 1 volt will remain there as it is. So 0.5 minus 1, that is minus 0.5 voltage. Well and good. Let's move on to the next question. This is a very good question. Try it on your own. Okay. So let's see it. The switch S1 is closed for t equals to 0 to t equals to 4 seconds. Okay, this S1 is closed for t equals to 0 to t equals to 4 seconds and is opened after that. And now they are not telling about S2, so we will consider it as open for t equals to 0 to 4 seconds. So circuit for t2 t equals to 0 to 4 seconds. Circuit for 0 to 4 seconds. Okay, so the switch is open. So this one is closed, this one is open. What is the condition? This is the condition. 2 volt, 2 Henry. And eventually they are talking about the current, how much time it will take for inductor current to go to 0 after switch S2 is closed. So they are talking about the current. Now I will write down the current equation. This is my IT. So my IT will be Vt by L. Why Vt by L? Voltage is changing? No. The voltage across the capacitor, voltage across the inductor is constant. That is 2 volt. The voltage across the inductor is 2 volt. That is constant. Higher end is at 2 volt, lower end is at 0. So 2 volt is constant there. Okay. So it will be 2t by L. L value is 2. So it will be t ampere. Right. So the current will rise from 0 to 4. Right. Basically the current waveform will be something like this. It will rise from 0 to 4 till 4 seconds. What is the value of current at t equals to 4 seconds? That is 4 ampere. Right. This is my IT. So that is I at 4 ampere would be 4 minus, you can say, that would be 4 ampere. Now what is happening? This S switch. So now what is happening? This switch S1 is opened and S2 is closed. Okay, S1 is opened and S2 is closed, but it will carry on this current, right? Because inductor has the property of carrying its current. So it will be carrying this current. So for t greater than 4 seconds, what is happening? 2 Henry inductor is there, nothing will happen to this. 2 volt, nothing will happen to this. This switch is closed. This switch is closed. So here I will have 6 volt. Right? And this switch is opened. And initial current is there. That is 4 ampere. Right? 4 ampere. Now tell me one thing, what is happening? An inductor is there. 2 volt is there at this end. Okay? And 6 volt is there at this end. And 4 ampere current is flowing downward. Now tell me in what direction the current will flow. You are having 6 volt here and 2 volt here. That means 4 volt at upward direction. Are you getting my point? Now this I dash t current will flow. Did you get my point or not? Basically, if I am calling this as my IT, so my IT would be 4 ampere minus I dash t, because you are having collectively 4 voltages from down to up. Here you are having 6, here you are having 2. That means you are having 4 volt constant 4 voltage. You are having 4 constant voltage in this direction. In this direction, 4 volt is there. That will induce the current in the opposite direction, right? It will induce the current in the opposite direction. So initially 4 ampere is there. Now this 4 volt is inducing the current in the opposite direction. Like 40 by L, or you can say 40 by L. L you can write. L value is 2 Henry. So basically it would be 4 minus 40 by 2. So the current will be 4 minus 2t. This will be IT, right? So when does IT goes to 0? So t value you get is 4 by 2, right? At 2 seconds. So at 2 seconds, your current goes to 0. So what did you understand? In 4 seconds, there was 4 ampere current. 4 ampere current was developed because of this 2 volt. Now, because of 4 volt, there will be current in the opposite direction. So in 4 seconds, 4 ampere current was developed because of 2 volt. So because of 4 volt, how much current will be developed? In 2 seconds, that will also be 4 ampere. Are you getting my point? That I was saying that 2 volt developed 4 ampere current. It took it 4 seconds. Now you need 4 volt to develop 4 ampere current in the opposite direction. How much time it will take? If the voltage is doubled, that means it will take it lesser time. 2 seconds it will take. That is the answer. Or you can solve by this method as well, the way I have solved. Right? What did you see? First you see that there is 4 ampere current that is set up. Now there is opposite voltage applied that will reduce the current. How it will reduce the current? In the negative direction. So 4 ampere is already there, and this will reduce the current 40 by L. So this is the current. Okay. So this is how it will go. So the total graph would be looking something like this, that with the lower slope, first it was rising. Okay, it took it 4 seconds, and then with the faster slope it will reduce and keep on reducing, right? This will be the graph of IT, right? This will be the graph of IT. This is 4 seconds, this is 6 seconds, right? This is seconds. This current is 4 ampere. This is the graph of IT. I hope you are understanding it. Let's move on to the next question. You have to find the steady state value of V naught. So steady state. What happens at steady state? What happens? Inductors are shorted. So this will be shorted, this will be shorted. So if you short them, what will happen? This is 4 volt, this is shorted, this is shorted, right? 4 volt shorted, shorted. Now this is saying I will have 4 volt here, and this ground is saying I will have 0 volt here. That means KVL invalid. Are you getting my point? What did they ask? They asked at steady state what will happen. At steady state, inductor will be shorted. So I short them up. Okay. This is saying it will have 4 volt. This is saying it will have 0 volt. KVL invalid. So in this case, what do we do? At t equals to infinity, that means omega equals to 0. Right? At steady state means DC. So DC means omega equals to 0. That means inductor is providing very less impedance. Inductor impedance very low, right? So what will happen to parallel combination of RL? Tell me. Parallel combination of RL. This is very low, this is a finite value. This is very low, this is very low, this is a finite value. So how it will be replaced? With simply inductor, right? Like 1000 parallel with 1 kilo ohm. So 1000 parallel with 1 ohm. So it would be 1000 into 1 upon 1001, which is nearly equals to 1 ohm only. So in parallel, we replace that with the lower one. Okay. So it will be replaced with the single inductance only. So this combination will be replaced with the single 3 Henry. Okay. So here I am having 4 volt here. Three Henry here, 1 Henry here, right? This is your V naught. So V naught at steady state would be 1 by 4 into 4. That means 1 volt. So this is your answer, steady state. Now there is one thing. Now I am saying this is the steady state. What I am saying is that this is the steady state. At steady state, inductor should not have any voltage. If I am saying this is having 1 volt, that means it is driving some current. If I am saying my inductor is having 1 volt, that means it is driving some current. So driving some current, that means it is getting charged. So this is not the steady state. Are you getting my point? At steady state, what do I say? At steady state, there should not be further charging or discharging. That means voltage should be 0. In case of capacitor, what do we say? The current should be 0. The current should be 0. Then only it is the steady state. Right? There will be no further charging, no further discharging. But if I am saying there is 1 volt there, that means there will be charging. So yeah, this is not the steady state. Okay. This is the steady state for voltage. This is the steady state for voltage. For voltage, not for current. Okay. Let's just call this current as I naught. So I naught will keep on increasing. I naught will keep on increasing after this. And now if you remember one thing, after this, if you remember one thing, I have taught you this concept. For I naught, this circuit is second order, right? For voltage V naught, this circuit is first order. For I naught, this circuit is second order. This circuit is second order. So I naught will increase and it will keep on increasing. Okay, there will be one ramp. Okay, there will be one transient and some other response as well. So that kind of I naught we will get, which we cannot explain intuitively. Why so? Because this is second order circuit. For that you have to apply Laplace transform. Okay, so by Laplace transform you can find the value of I naught, but that will be very complex. Okay, so that they will not ask, that's for sure. But for voltage they can ask, because for voltage it is first order circuit. At t equals to 0, what will be the V naught value? V naught value at t equals to 0, inductor will be open circuited. These both of the inductor will be open circuited. So V naught at t equals to 0 will be 4 volt. At t equals to infinity, what will be the voltage? It will be 1 volt. So from 1 volt, from 4 volt to 1 volt, it will decay, right? Initially what will happen? This is open circuited, this is open circuited. So this will be the case, right? 4 volt, this is the resistance R, this is grounded, this is also grounded. So this 4 volt will come there. So this will be 4 volt, right? 4 volt, and then at steady state, steady state of voltage. This is the steady state of voltage, not the circuit. Okay, this is the steady state of voltage. At steady state, we will be having 1 volt. That's why I took this question. This was the only good thing in this question. Oh, and also, if KVL is getting invalid, how will you solve the problem? This is how you will solve the problem that we have already seen, right? Let's move on to the next question. Now, this is a very good question, but we will be solving this question with the option. If you want to calculate the complete answer, I have told you, I have shown you the method, so you can get the complete answer. Now, most of the student, what they will do, since there is this impulse input, most of the student will solve by Laplace in the exam. Okay, and you can solve it as well, but it will give a very complex calculation. Okay, there will be some complex calculation. So how we have studied? Okay, let's take this circuit. Okay, let's take this circuit. So how we have studied? We have studied by the damping, right? This is delta T, and damping is independent of the applied input, right? It is independent of the applied input. 1 ohm, 1 Henry, and 1 Farad. This is VCT we are talking about. Okay, so first tell me what is the value of alpha. Alpha is R by 12, right? R by, this is series RLC, this is series RLC. So first we will find the value of alpha. Alpha is R by 12, so that would be 0.5. What is the value of omega? Omega naught, that is 1 by root LC, that will be 1. So here alpha is less than omega naught, that means it is under damped system, right? This is under damped system. So what will be your VCT? VCT would be e to the power minus alpha t, 0.5 t, C1 cos omega dt. Omega d is 1. Sorry, this is not omega d. Omega d is something else. What is omega d? Omega d is root omega naught square minus alpha square. That is 1 minus 1 by 4. That means it is root 3 by 2. Right? All this we have studied. That's how I am writing it. Or if you find alpha and omega naught, then you can simply find the roots. After finding the roots as well, you will get the same thing. Right? You will get this same thing. Okay. So this is my VCT that I am getting. Now I need to find the value of C1 and C2. C1 and C2. Now in the exam, what I will do? I will go to the option. This option is cut. This option is cut. A and B are cut. Why both of them are cut? Because they don't have any sinusoid. If underdamped system is there, that means the response will look something like this. So there has to be some oscillations. If oscillations are there, that means there has to be some sinusoid or cosinusoid. So these two options are left. In this problem, at t equals to 0, what you are getting? At t equals to 0, you are getting 2 by root 3. And in this one, you are getting 0. So what is the value of VC at t equals to 0? That is the case now. That's it. What is the value of VC at t equals to 0? That is 0 volt. This is the answer. That's it. Oh, sorry, 0, sorry. So this is the answer. Option D is correct. How did I get there? First, I will see the damping. What is damping? Damping is underdamped. If it is underdamped, that means it will certainly have sinusoid or cosinusoid. How did I check the damping? That is R by 12, 1 by 2 and omega naught is 1. So I got to know that omega naught is greater than alpha. That means it is underdamped. If it is underdamped, it will have sinusoid and cosinusoid. These two options are cut. Okay. Now I will think of sine and cosine. At t equals to 0, what is VCT? That is 0 volt. Right? There is no initial voltage, so it will be 0 volt. Right? And before deciding it, if it is 0 volt, you should always check one thing. What is that one thing? If there is a case of infinite current through the capacitor, if there is infinite current through the capacitor, then voltage may change instantaneously. But is there any infinite current in the capacitor? That we will see. So what is my circuit at t equals to 0? Circuit at t equals to 0. Okay, see it with very high concentration. Okay, this is delta t. What is happening to my inductor? Inductor is open circuited. This is my resistance and this is my capacitor, right? This is the scene, right? Capacitor shorted, inductor open circuited, because initial no current is there in the inductor, so it will be open circuited, and initially there is no voltage across the capacitor, so it is shorted. And this is my 1 ohm resistance. So 0 volt, 0 volt, here I will have 0 volt, here I will have delta t. So across the inductor I am having impulse voltage. Across the inductor I am having impulse voltage. Across inductor there is impulse voltage. That means it will generate immediate current. Immediate current. So if I am calling this current as I, so I of 0 plus will be what? Tell me what it will be. Vs by L. Not Vs by L, 1 by L. It will be 1 by L. 1 by L, that means it will be 1 ampere. How did I get there? Impulse, this is 1 Henry. The voltage across is delta T. What will be the current? IT. IT would be 1 by L integration Vt dot dt. That means 1 by L, what is Vt? That is delta T dt. So what it will be? 1 by L into L value is 1, so 1 into ut. So it is generating an immediate current, right? So even if there is an immediate current, the current is finite. What is the value of current? That is 1 ut. So if there is finite current across in the capacitor, that means it will not charge instantaneously. In capacitor there is finite current. In capacitor there is finite current. That means no instantaneous charging. Instantaneous charging, right? That means no instantaneous charging. That means Vc 0 minus, that was 0 volt, will be equals to Vc 0 plus, that would be 0 volt only. So what is the option that we are getting? That is this. So always while solving with the impulse input, okay, if there was step input, you don't need to worry. If there is impulse input, something can happen. So I just checked that because of this impulse input, there is impulse voltage going across the inductor. If there is impulse voltage, that means it will generate an instantaneous current. That instantaneous current will flow through the resistance and the capacitor. But the current is finite, that means the capacitor will not change its voltage immediately. But here the inductor change its current immediately. Since they are asking about VCT and voltage across the resistance, that means they are asking about VRT. So VCT and VRT they are asking, right? If they had asked for ILT, then it would have been a very interesting problem, because people would think that current initially will be 0, but IL, let's just call this current as IL. But IL 0 plus is not 0, it is 1 ampere, right? So that's how you should be very much comfortable with the concepts. If you are not comfortable with the concept, you will be applying Laplace transform and you will get to the final answer. But most probably you will do it wrong in the exam. Try applying Laplace transform. I am pretty sure most of the students will not be able to solve that expression. What will be the expression? Expression for this, it will become 1 upon s square plus s plus 1. Now factorize it and get to this answer. So yeah, people can solve, that's for sure. People can certainly solve it. Okay, but yeah, it will take time, right? It will take time. Okay, so yeah, so but if you are very good with the concepts, then you can certainly you can cut these two options by thinking what is the damping. It is underdamped, so it has to have some sinusoid and cosinusoid. At t equals to 0, what is the capacitor value? That is 0 volt. So if I put 0 in this option, I will get root 2 by 3. If I put 0 in this option, I will get 0. So this is my final answer. Are you getting my point? Okay, so this is how I solve it. Now try solving the other one on your own. This one. So how these two options are cut? Because they don't have any sinusoid or cosinusoid. So every expression will have sinusoid or cosinusoid because underdamping is there. So if you talk about VRT, C1 and CT, here I will write that we know at t equals to 0, VC 0 plus will be 0 volt. Also, there should be what? There should be oscillations. There should be some oscillations. What do I mean by oscillations? Because it is an underdamped system. Underdamped system, that means it will have sinusoid or cosinusoid, right? So only option D is correct. That means option D is correct. Right? Now try solving it on your own for VRT. For VRT. You can solve on your own for VRT. So what will be my VRT? My VRT will simply be e to the power minus alpha t C1 cos omega dt. Omega d is root 3 by 2. C1 cos omega dt plus C2 sin omega dt. Right? Tell me the value of VR at t equals to 0 plus. Is it 0 volt? VR at t equals to 0 plus. Is it 0 volt? Since there is an infinite voltage across the inductor or impulse voltage across the inductor, there is an instantaneous current. The value of that instantaneous current is 1 ampere. Because of this 1 ampere, the voltage across the inductor is 1 into 1, that means 1 volt. 1 into 1, that is 1 volt, not 0. Why is it not 0? Because impulse voltage across the inductor, and that will generate instantaneous current. And that will generate voltage across inductor. Sorry, voltage across, not inductor, what do we say? Voltage across resistor. Are you getting my point or not? If your concepts are that much clear, then only you will be able to solve these questions very quickly. In the exam, if my concepts are very clear, so yeah, what will be the answer? Tell me. At t equals to 0, you shouldn't have 0, right? So at t equals to 0, you are having 1. At t equals to 0, if you put t equals to 0, at t equals to 0, what you are having? Here it will be 0, so it will be 1, it will be 0. So at t equals to 0, you are having 1 volt here. For this, you are having 1 volt. And at t equals to 0, you are having 2 by 3 volt here. So which answer is correct? Option B is correct. Right? So at t equals to 0, you need to have 1 volt. And that is there in option B only. So I am writing, if you put t equals to 0 in option B and D, you get 1 volt in option B and B. So correct answer is option B. Go to my point? Well and good. Okay. So in exam, what I will see? First, I need to calculate VCT. Okay, impulse voltage is there. Okay, I need to be more. I need to have more concentration now. Impulse voltage. Okay, impulse voltage will be there across the inductor. It will generate an instantaneous current, but the current is finite. So VC 0 plus will remain 0 only. Since I have checked the damping, damping is under damped. Okay, that means it will have sinusoid or cosinusoid. Option A and B are cut. Option C and D are remaining. VC 0 plus is 0 volt. So it has to be sinusoid. Option D is correct. In case of voltage, in case of resistor voltage, since there is instantaneous current, that is 1 ampere, because of that 1 volt will be there across the resistor, and it should have sinusoid and cosinusoid. If there is no sinusoid and cosinusoid in option A and C, so A and C are cut. Now B and D are remaining. If I put t equals to 0, only in option B I am getting 1 volt. That means that is the correct answer. That's it. Hardly it will take 2 minutes to solve these kind of question. But if you go by Laplace, it will take you around 10 to 15 minutes. So this was my target for introducing this course. By this course, you are much more comfortable in these kind of concepts, right? And this will save a lot of time in the exam. Also, it will give you a lot of confidence as well, because other people will not be solving like this. That's for sure. So this was my motive, and nothing more can be asked in the exam apart from these concepts. That I can guarantee you. Everything that I have told you, that's more than enough. Nothing more can be asked. And now people will say, why I am teaching too much deep. Now this is the gate question only. This is asked in the exam only, and that's why I am teaching too much deep. No one teach what will happen if infinite voltage is there across the inductor. So that's why I teach too deep, so that you have a very clear idea of the concepts. अब इतना बढ़िया clear idea होगा तो एग्जाम में बहुत जल्दी करोगे आंसर. And this is how I attempted my exam as well, right? So that's why I teach that much deep. I hope you are understanding my point here now, right? If you are understanding the point, please do comment down. Okay. So let's move on to the next question. This is also a very good question. So this will also give an insight why I teach too deep. Okay. So yeah. So L di by dt plus IR equals to some voltage. Can you think of the circuit? What will be this circuit? Voltage into current into resistance plus L di by dt. What they are applying here? Current is same everywhere. That means they are applying KVL. And this is series RL circuit. So this is simply a series RL circuit with a voltage source of, let's just call this is my V in T. Okay. This is R and this is L. Right. This is my series RL circuit. And there is this current I. So V in T is IR plus L di by dt. So simply what is IR? What is V in T? That is V naught 1 plus B e to the power minus RT by L sin T ut. That is equals to IR plus L di by dt. So simply this is my circuit. Okay. Now what they are asking? They are asking the steady state value of current. What you can do, you can solve this question by Laplace transform as well. I will solve by Laplace as well, and I will solve how you will solve quickly as well. So let's solve by Laplace. So what is my equation? V naught into 1 plus B e to the power minus RT by L sin T ut. But for solving by Laplace, you need to have a very good idea of Laplace transform. Okay, then only you will be able to solve. Okay, very good idea of Laplace transform you need. Now there is one more thing, like people will say, why are you not taking this I naught in the consideration? I naught, V naught by R. Look, my I naught will come here, no? IR plus L di by dt, I naught plus some current. So this differentiation will go to 0 only. So eventually this equation will come only, right? I have told this concept while teaching the concepts as well. What I am saying, I have some initial current that I know, but while writing the voltage, it will not come in action. Because in case of inductor, if I am writing the voltage, there is no meaning of initial current. Even if it is having 100 ampere initial current, it will not affect the voltage. Voltage will simply be L di by dt. So this I naught will not come in action. So this is just to confuse you. Okay. So let's just forget about this. This is my final equation. This is the equation I am having. So I need to apply Laplace here. So I will just break it down. 90 ut plus IR plus L di by dt. Okay, I am taking Laplace transform. What will be the Laplace transform of this? This will be V naught by S. Now for this function, B V naught is becoming a constant. Now tell me what will be the Laplace of this function? That will be 1 upon S plus R by L whole square plus 1. How many of you understood this point? Here I will write. What is the Laplace of sin t ut? That is 1 upon S square plus 1. Right? What is the Laplace of e to the power minus at f of t? That will be f of s plus a. This is what is happening here. Laplace transform of sin t ut is 1 upon s square plus a square. E to the power minus at is applied. So s plus a. Right? So instead of s, I will write s plus a. That is r by l whole square plus 1. This is how I wrote it. Okay. So you need to have a very good idea of if we are writing Laplace transform of this function. After studying control systems and signal system, you will be very much comfortable with this. But you should have this idea. This I have already taught you as well how to write Laplace transform. So e to the power minus e to the power minus at ft. So s in s, this minus a will be added actually. So this a is added. And what about this? This will be easy. This will be I of s into r plus ls. Right? Differentiation will give me s. So I of s will come in common. So this will be my final answer. So what will be my I of s? So this should be capital I of s. So what will be my I of s? My I of s will be V naught by s. Here V naught, no, not V naught by s. Yeah, I can write it like this. V naught by s plus B V naught into 1 plus into 1 to s plus r by l whole square plus 1 upon r plus ls. Plenty wrong with this. Now I need to find I of infinity. I need to find I of infinity. That means I can apply final value theorem. This is what? Final value theorem. If you have forgot it, just go and check. What was my final value theorem? If I need to check it, I can check it like this. Right? So what will be my S of I of S? It has hand. So what I will do, I will just multiply V naught plus B V naught. I am multiplying this with S. So it will be remaining V naught only. And if I multiply this with S, it will go like this. S plus R by L whole square plus 1 upon R plus Ls. With the limit S tends to 0. So if I put S equals to 0, this will become 0 and this will also become 0. So finally my answer would be V naught by R. So my I of infinity is V naught by R. Right? My I of infinity is becoming V naught by R. So this is my final answer. Okay. This is one method by Laplace transform. Other method. Method 2. At t equals to infinity, this is what steady state mean. At t equals to infinity, what will happen? What will be my v in at t equals to infinity? This is my v in at t equals to infinity. This will go to v naught only, right? at t equals to infinity, my input will be 0, v naught only, because this factor will come to 0. At infinity, if I put, this factor will come to 0. So my input will be only v naught. So my v in will be v naught only, and inductor will be shorted. Inductor will be shorted. So what will be my circuit now? V naught voltage, R, and inductor is shorted. So what is the current now? I of infinity. I of infinity is V naught by R. That's it. If you just have very good idea of the concepts, then you can find it very easily. At infinity, what is my steady state voltage? My voltage is also a function of time. But what is my steady state voltage? My steady state voltage is V naught. And what is my steady state condition? Steady state condition is that my inductor will be shorted. Simply the current will be V naught by R. That's it. If you are thinking about steady state, you don't need to think about initial condition. You don't need to think about anything. Just make the circuit at steady state. At steady state, my voltage will be V naught. At steady state, my inductor will be shorted. So simply current will be V naught by R. That's it. While thinking about steady state, don't think about initial condition. Don't think about anything, time constant, anything. Just steady state. Okay, what is happening at steady state? Steady state means t equals to infinity. If you put t equals to infinity, V naught is my voltage. What is the condition? Inductor is shorted, current will be V naught by R. That's it. That is my answer. Or you can solve by Laplace. If it doesn't click you, then this much of calculation you will do and you will get to the final answer. But if it clicks you, two-step, right? Now this question, I want you to find the expression of Vxt. So first I need the value at t equals to 0. What is the order? What will be the order of the circuit? That will be first order only, because there is only one storing element. So first order it will be only. So Vxt you need to find. Okay. So for t less than 0, first not for t less than 0, the switch is being opened at t equals to 0, right? And this is a DC source. So I need to check what is the condition at t equals to 0 minus. So what is the condition? This is 20 ohm. This is 2.5 ampere. Right? And this will be shorted. Sorry. This is closed, no? Yeah. This is the circuit actually. This is closed. And the inductor will be shorted. And this 20 ohm will be there. This will be the circuit. For t equals to 0 minus, this is closed. So inductor will be shorted. Steady state would have been reached, right? This is 20 ohm. This is also 20 ohm. Right? So Vx at t equals to 0 minus is 0 volt, but that's not a matter of concern. What is the matter of concern? In case of inductor, only the current is a matter of concern. So what is the value of IL 0 minus? Tell me, if you can solve the network very nicely, what is the value of IL 0 minus? This current has two paths, either to go this way, either to go this way. Where it will go? This way, right? Why? Because this is complete short circuit path, complete shorted path, right? So this is complete shorted path. So IL 0 minus will be 2.5 ampere. That will be carried forward ahead. Now forget about this. This will not be carried forward, right? But this will be carried forward. So circuit at t equals to 0 plus. This is 2.5 ampere, 20 ohm. This inductor is there. Five ohm and 20 ohm. 5 Henry and 20 ohm. Initial current is there, that is of 2.5 ampere. So now this 2.5 ampere current will flow in this direction. Now voltage drop they are asking in this direction. So what will be the value of Vx 0 plus? That will be 2.5 into 20, but minus sign. It will be 5 volt. No, 50 volt, minus 50 volt. Am I doing it correctly? 2.5 into 20. What is 2.5 into 20? That is 25 by into 2. So that will be minus 50 volt. So Vx 0 minus is minus 50 volt. Okay. Yeah, one more thing. Yeah. So student may get it out. Now this 2.5 ampere current will be flowing here only. What is the guarantee? What is the guarantee that this 2.5, you are saying that there is this current. Now this 2.5 ampere has three paths, either to go here, either to go here and go here. Now I am saying that this 2.5 ampere will be flowing in 20 ohm resistance only. How am I saying this? Tell me one thing. This 2.5 ampere current will be going this way only because it has only one path to go here only. And then 2.5 ampere will be coming here only. Whatever the current leaving, the same current is has to take. In basics of network, we have studied it. Whatever the current leaves from a source, whether it is voltage source or current source, the same current it has to take. If there is 2.5 milliampere current leaving from here, it has to take 2.5 ampere now. So here 2.5 ampere, here 2.5 ampere, here also 2.5 ampere. That means this complete 2.5 ampere is flowing in this loop only. So this 2.5 ampere current is not going outward. Even if it was 10 ampere, even if it was 100 ampere, this would have been flowing in this loop only. Because whatever the current it is giving, it has to take the same current. Right? So there is no other path. If this current goes in this path, I don't know whether it will return or not. But I can see one thing here. This is 2.5. This is also 2.5 and this is also 2.5 because it has to take the same current. So that means the complete current is flowing in this manner. Even if it was 10 ampere, it would have been flowing, 10 ampere would have been flowing there only, in that loop only. Okay. So 2.5 ampere will be flowing this way only. Now what about this 2.5? This 2.5 will go. Here there is 2.5 ampere current, no? This current and this current would be same, right? Direction is different, sorry. This current and this current would be same, right? This current and this current would be same because there is no other path for this. So here also I have 2.5 ampere. So in the complete loop, this 2.5 ampere current will be flowing. So that's why I am saying Vx0 minus will be minus 50 volt. What will be circuit at t equals to infinity? Circuit at t equals to infinity. This inductor will be shorted. Sorry, open circuited. Sorry, it will be shorted. Sorry. It will be shorted. 2.5 ampere. This is 20 ohm. Now this 2.5 ampere has nothing to do with this circuit. It has nothing to do with this circuit. This 2.5 ampere current will always flow here. But at t equals to 0 minus, what was the case? This current was going from here. Now it sees the short circuit path. It goes here. It goes here. It goes here. And then return back from this path. It flows like this when it was shorted. Now if it is open circuited, it sees only one path to go here. That is this path. Then goes here. Then it has to return back like this. So it has to come like this only. So that complete 10 ampere current will be flowing in this loop only. And complete 2.5 ampere current will be flowing in this loop only. So no part of any current will go here. Right? This is 20 ohm. Okay. This is my Vx I am talking about, right? So Vx at infinity will be 0 volt. So minus 50 to 0 we are coming. Now the thing is time constant. So tell me what will be the time constant? What do you think? L equivalent is 5. What will be R equivalent? What will be R equivalent? What will happen? This current source will be open circuited. This current source will be open circuited. This 20 ohm will have no path. Like for time constant, what will you do? You need to find time constant, right? So what will you do? This 20 ohm will remain there like this because the current source will be open circuited. And this is your 5 Henry and this is your 20 ohm. Henry and 20 ohm, right? So tell me what is L equivalent here? L effective, that is 5 Henry. What will be R equivalent? R equivalent will be 20 ohm only across this, because this 20 ohm will not come in action because this is open ended. So if you are finding equivalent resistance at this node, that will be 20 ohm only. So R equivalent will be 20 ohm only. So what will be my tau? That will be 1 by 4 second. So if I am writing my Vxt, that would be minus 50 e to the power minus t upon tau minus 40 ut. That will be my final Vxt. Okay, so it was a very good question. What did we see here? First we saw that 2.5 ampere current was flowing in the inductor, so initial current was 2.5 ampere because it has this path. Okay, so whenever you are solving a network problem, network is a very deep subject, and I hope you are studying it this much deep for the first time only. Okay, so now at t equals to 0 plus, what you are seeing, it is 2.5 ampere current it is having, so the same 2.5 ampere current will be flowing through the 20 ohm resistance, so it is giving me minus 50 volt. What also I saw that the other 2.5 ampere current will keep on flowing here, even if it was 100 ampere, no part of the current would come to this loop, so it will keep on flowing in one loop only. Now coming to this circuit at t equals to not 0, circuit at t equals to infinity. So circuit at t equals to infinity, the inductor will be shorted, so Vx will be 0 volt, and also this 2.5 ampere current will keep on flowing there. Okay, so this will be my voltage, minus 50 e to the power minus t upon tau. Now I need to find tau. So how will I find tau? The inductor, the current source will be open circuited, so 20 ohm will go out of the action. So across 5 ohm, 5 Henry, I have only R equivalent, that is 20 ohm. So my tau will be 5 by 20, that means 1 by 4 second. So my Vxt would be minus 50 e to the power minus 40 ut. That's it. So this was a very good question. Let's move on to this question. You have to find the Vc1, Vc2, Vc3 across capacitors in the given circuit under steady state. Very easy question. At steady state, what will happen? 100 volt is there. This is 10 kilo ohm resistance. At steady state, what will happen? This will be open circuited. Inductor will be shorted. This 40 kilo ohm will be there. This 2F will be open circuited. This inductor will be shorted, but there is something, so I will make it like this. And there was also something, so I will make it like this. And this 25 kilo ohm will be there. And this 3F will be open circuited. Right? And this is 40 kilo ohm. This is Vc1. This is my Vc2. This is my Vc3. Let's just call this as IL2 and this as IL1. I will find all the values. Tell me what will be Vc1? Vc1 at infinity. This circuit will not come in action because this is open circuited. So this will not come in action. So 40 by 50 into 100. That means 80 volt. Tell me what will be Vc2 at infinity? Look, this 80 volt is coming here, right? Now I have taught you this concept. If there is this 80 volt at steady state, and this was my circuit, this circuit we have taken, right? C1, C2, R. At steady state, what I am saying, this inductor will be, this capacitor will be open circuited, and this capacitor will also be open circuited, right? Now you will say this is 0 volt and this is 80 volt, but you can't define the voltage here. These are open ended. So for that, what we need to do at steady state, we need to see what is omega equals to, what is omega? Omega is 0. So omega equals to 0. That means this will provide very high impedance. So this series combination of RC will be replaced with C1 and this will be replaced with C2, and now simply you can divide 80 volt. The same thing is happening here. Now if I haven't taught this concept, how would you able to solve this problem? Now at omega equals to 0, now you can't say like, this voltage is 80, okay, but you can't define this voltage. This voltage is 0, but you can't define this voltage, right? So for that, again you have to see what at omega equals to 0. At steady state means omega equals to 0. At omega equals to 0, this is providing very low impedance, right? At omega equals to 0, this is whatever it is, this is a finite, low or finite, you can say finite impedance, but this will provide very high impedance. This will also provide very high impedance. So your complete circuit, very high impedance. So the complete circuit will be replaced with 2F and 3F. Now your 80 volt will be divided between 2F and 3F. So how will you divide? 80 volt will be divided. Now don't do mistake here, okay? Voltage will be divided in inverse proportion. So 80 into 3 by 5. So that will give me 6. So 48. right? Yeah, and the rest one will give me 80 will be divided into 3 and 2, so it will be 2 by 5. So it will give me 32 volt, right? 32 volt. So this is the answer for VC1, VC2 and VC3. What about IL1 and IL2? IL1 would be, IL1 at infinity would be what? This is a complete circuit, so basically 100 by 50k, that means 2 milliampere. And what about IL2? This is providing very high impedance, so complete circuit is providing very high impedance, but that means current will be 0, because this is open circuit as well. Now you can't say the circuit is replaced like this and there will be impulse current. This is not happening at t equals to 0, this is happening at t equals to infinity, right? So this is very high impedance, this is very high impedance, this is not very low impedance. You can't say that V by 0, that means infinite current is there. No. This is actually very high impedance. We just replace the circuit with the capacitor because they are providing very high impedance with respect to the other component. That's why we are replacing the capacitor with the single. That's why we are replacing with the circuit with the single capacitors only. Okay, so you can't say there is impulse current. There is this zero current only because they are open circuited. So the current IL2 at infinity would be 0 ampere. Got my point? I hope you are understanding. Okay. This was also a very good question, and this was asked in GATE as well. Now people will say, why am I teaching those concepts? That's why I am teaching those concepts, because these kind of questions are asked, and in the exam you will be confused. You will just say open circuit, short circuit, or whatever the voltage. If your concepts are crystal clear, then you will not be confused at all, and this will give a huge advantage. Okay, like what I will say is that in communication system you can't be that much of comfortable, no matter how much you have studied. I studied communication for 6 months around during my probation. Not 6 months, 4 to 5 months. And in the exam, I scored 4 out of 11, 4 out of 13. In my time, it was asked for 13 marks, and I scored 4 out of 13. In my time, even network and analog was asked on moderate level, not easy, not very tough. From moderate to tough, it was asked. But I was so comfortable with these subjects that I could solve this problem very fastly. Same with the control system, same with the signal system. So here I took the advantage. So if we are studying some concepts deeply, and it's not that we are wasting time, right? We are studying concepts so deeply that even if in the exam they are asking moderately or tough, we will be able to solve, and we will be able to solve quickly and with more confidence. Like if you know all these concepts that I have told, so you will be solving this problem with very much confidence, and it will increase your confidence in exam, and you will be able to solve further question more accurately. This is what happens in the exam. You don't know the atmosphere of exam. If you are solving one by one question confidently, then your accuracy will be great. This is what happens. This is what actually happens. Okay, so that's why I am saying, that's why I focus more on these concepts. I will teach this analog, network, digital and signals very deeply. Okay, these not very deeply, whatever you are required, but at least whatever they ask, whatever IIT ask, you should have a crystal clear concept. It's not that you are just तुक्के मार रहे हो आप, तुक्के नहीं लगाने, हमें एकदम बढ़िया कॉन्सेप्ट से एकदम प्रिसाइज आंसर देना है. So these subjects will be studying very deeply, and even same with the communication, EDC and EMFT. Okay, yeah. So in this you have to find the current through 1 ohm resistance. Okay, so here is one this DC source and there is this AC source. So what we can do, we can apply superposition. So considering only one volt, only 1 volt. Look, in option they are not talking about transient, so they are talking about only steady state. Okay, in option you can see they are not talking about transient, so they are only talking about steady state. So at steady state, they should have actually written that they are talking about steady state, but we will consider they are talking about steady state only. So at steady state, what will be the condition? Inductor will be shorted and capacitor will be open circuited. So this will be the condition only, right? So because of this, the current through the resistance, let's just call this current as I. Okay, we are calling this current as I. IT we are calling. Because of this I of infinity, I am writing I of 0 here. Can anyone explain why this is steady state? because this is coming from t equals to minus infinity. This is also coming from t equals to minus infinity. There is no ut written. So all are coming from t equals to minus infinity. So steady state will be reached at t equals to 0 only. Okay. So let's just, at steady state, I will just write I. So I will be 1 ampere. I1 will be 1 ampere actually. I will call I1 because IT is the complete current. So it will be 1 ampere. Now steady state analysis for this current, considering 5 cos 2t. Considering 5 cos 2t ampere, right? So this 1 volt source will be gone because we are applying superposition, and then there is this resistance, and then there is this capacitor. This is L, this is R, this is C, and I am applying 1 ampere current source, not 1 ampere, sorry, whatever the current source is there, that I am applying. 5 cos 2t. Now this and this combined will give me how much impedance, because I need to find current in this. So this and this will combine give me Ls into 1 by Cs upon Lc plus 1 by Cs. So it will give me Ls upon Lc s square plus 1. This is the impedance they are providing me. So basically you have this circuit that has impedance. I will make this block only. It has some impedance, that is this, and it has a resistance, that is 1 ohm, right, or 1 kilo ohm, 1 ohm, and then it has a current source of 5 cos t, and you need to find the current here. Let's just call this current as I2, not I1. I2, and this is 5 cos 2t. Since the value of L and C are given, we can find the value as well. L is 1, C is 0.25. So L is 1, C is 0.25. So it will be s square by 4. Is there any? Yeah. C is 0.25, so it will be s square by 4. So it will be 4s plus s square plus 4. Right? What did I do? I just put the value. L is 1, C is 0.25. So this function is 4s upon s square plus 4. Right? Now you need to divide the current in the inverse proportion. So what will be I2 of j omega? I2 of j omega, that will be, I2 of j omega will be 4j omega upon minus omega square plus 4 upon 4j omega upon minus omega square plus 4 into plus 1 plus 1. Let's just call this current as I in t into I in j omega. How did I write it? This impedance is 4s upon s square plus 4. 4s upon s square plus 4. And the other one is 1 ohm. You have to divide in inverse proportion. How will you divide? 4s upon s square plus 4 upon 4s upon s square plus 4 plus 1. Replace s with j omega. If you replace s with j omega square on both sides, s square will be replaced with minus omega square, because j square is minus 1 and omega square is omega square. J square is minus 1, so it will be minus omega square. Right? So s square is replaced with minus omega square. So that's how I divided it in inverse proportion. Okay, so it will be 4j omega upon 4j omega minus omega square plus 4. Omega value, omega naught is 2 here. I should have put an omega naught here, right? I of j omega naught, I2 j omega naught, you can say omega naught equals to 2 here, right? Here, from here I will go to steady state sinusoid analysis that we are doing. In the last lecture only we have studied it. Just find the current in the frequency domain and then just convert it, right? So IT of j omega naught you can write as, this will be 8j, this will be also 8j, I of j omega. So simply I2 of j omega is becoming, so this will be cancelled. So I2 of j omega is simply becoming I of j omega only. So I2 of t would be simply IT only. So what will be I2 of t? I2 of t is 5 cos 2t. I2 of t is 5 cos 2t. What was your I1 of t? I1 of t was 1 ampere. So what will be your total current I? Total IT would be I1t plus I2t. I2t. So it would be 1 plus 5 cos 2t. This will be your IT, right? Well and good. Also, when you study resonance, you will realize that this 2 is resonance frequency. For this circuit, this 2 is resonance frequency. What is resonance frequency? That is 1 upon root LC. So 1 by root LC, that means 1 by 4. Sorry, 1 by 1 by 4. 1 by root 1 by 4. So it will be 2. So resonance frequency is 2. That means all the current will be flowing through the resistance only. So no current will go through the inductor, no current will go through the capacitor. So 5 cos 2t, complete current will be flowing through this 1 ohm resistance. So 5 cos 2t, and from here you are getting 1 ampere. So 1 plus 5 cos 2t. After resonance, you will be able to solve it very quickly, because at resonance frequency, all the current flows through the resistance only in case of parallel RLC circuit. Okay. Otherwise, by this concept we have studied, like first find the impedance, then after finding the impedance, you can divide the current in the inverse proportion, and then you got to know. But in the exam, you will be able to solve in within 1 minute, because you know it is the resonance frequency. Okay. Let's move on to this question. Here as well, there are two sources applied, DC and AC. Okay. And steady state output is expressed at P plus cos omega t minus 5. Omega CR value is given. This value is given, omega CR. Okay. This value is given, that is 2. Then find the value of P and Q. So considering only 5 volt, again superposition we will apply. Considering only 5 volt, what will be the steady state V naught? At steady state, what will happen? Capacitor will be open circuited. So here I have 5 volt, capacitor will be open circuited, right? This is my V naught, V naught T, V naught 1 I will say. V naught 1 at infinity would be 0 volt, right? V naught at infinity 1 would be 0 volt. That shows what? P is 0, right? That shows that P is 0 because DC component is 0. Now talking about AC, that is 3 cos omega t. Considering 3 cos omega t. Considering 3 cos omega t. Omega they haven't given, but omega RC they have given. That is 2. Okay. This is CR circuit, not RC circuit. Okay. This is CR. And this is 3 cos omega t here. AC source is there. That is 3 cos omega t. And this is my V naught. Right. So what will be my V naught as by Vns? That will be R upon R plus 1 upon CS. So it would be RCS upon RCS plus 1. So that would be J omega RC upon J omega RC plus 1. This is V naught J omega into V in J omega. So omega is here omega RC is 1, no, not 1, 2. Omega RC is 2. What is the magnitude of H of omega naught? You can say this is actually omega naught RC now, right? So that is 2. So it would be 2 upon root 5. That would be the magnitude. If you put 2 here, 2 square 4, 4 plus 1, 5, and then under root 2 by root 5. And what will be the magnitude? Yeah, the magnitude will be interesting now. What will be the magnitude? The upper one will give me a magnitude of 90 degree, and lower one will give me a magnitude of minus 10 over 2. How? What is the expression? This is the expression, right? So what is the magnitude? Upper one 2, lower one 2 square, that will be 4, 4 plus 1, 5, 2 by root 5. That is the magnitude. How will you write the angle? 2j. 2j means somewhere here. That means it is 90 degree. 90 degree minus, what is the angle of this? This is the angle. That means tan inverse 2. Got it? So this is the angle. Okay. These are the things I have. So basically I can write my V naught T. That would be 6 by root 5. From here I am writing my V naught T. That would be 3 into this magnitude, 6 by root 5 cos omega t minus 90 degree plus tan inverse 2. So basically my Q value is 6 by root 5. So from here I go to know my Q value is 6 by root 5. This is my Q value and my P value was 0 and P was 0. Okay. They didn't ask the angle, they just asked the value of P and Q. So my Q was 6 by root 5 and my P was 0. Got it? DC we sold. From DC we are getting 0 volt. So P was 0. Now for Q, we got to know this is my V naught by V in S, that is j omega RC upon j omega RC plus 1. So my magnitude is 2 by root 5 and my angle is 90 minus tan inverse 2. Right? So then I put that angle here. Simply, okay, wait. This will not be negative. Why it will be negative? Okay, the angle I have written is wrong because angle is added, not subtracted. So just add it up. This will be added only, right? This will be the angle. Then I just wrote the angle and from there I got the value of Q as well. Okay. This is the last question, I guess. Yeah. This is the last question. The circuit is shown. You have to tell the steady state V naught value. Again, the same kind of circuit is there. Okay. Given what is the given omega naught here? V in T is Vp cos T by RC. So what is omega naught? Omega naught is 1 by RC. I just need to find V naught S by V in S. So what is my circuit? This is my RC circuit, RC and RN T. RC, RN T. This will be my V naught. So what this will give me? Parallel combination of R and C. That will give me R upon RCS plus 1. Right? R parallel with 1 upon CS. What this will give me? R upon RCS plus 1. And this will be my R plus 1 upon CS. What this will give me? That will give me R plus 1 upon CS. That means RCS plus 1 upon CS. So how will I write my V naught S? V naught S would be R upon RCS plus 1 R upon RCS plus 1 upon R upon RCS plus 1 plus RCS plus 1 upon CS. So here it will come RCS upon, you just need to solve it. This is simple mathematics. You can solve, right? RCS plus RCS whole square plus 2 RCS will there. So it will become 3 RCS plus 1. So this will be my V naught S. Into V in S, I forgot. Into V in S. So V naught j omega, that will be j omega RC upon minus omega naught RC square. This value I am writing. This is minus omega naught RC square. Okay. Plus 3 j omega naught RC plus 1. Right? Right? Yeah. And also omega naught here. Because at that certain frequency we calculate it. So what is the value of omega naught RC? That is 1. From here you got to know omega naught RC is 1. Simply at omega you will put 1 by RC. So omega naught RC is 1. So I will simply put 1 here. So this will become J, this will become minus 1, this will become 3J, and this will become plus 1. Right? V in J omega. So V naught J omega is becoming V naught J omega is becoming 1 by 3 V in J omega. Right? This is my V naught J omega. So simply my V naught is 1 by 3 V in T. 1 by 3 V in T. That means it is Vp by 3 cos T by RC. That is my V naught T. This is the final answer. Understood? Well and good. Easy question. Just find the transfer function. Complete mathematics is there. No concept is there. You just need to solve by the mathematics. You just go to know it is 1 by 3. 1 by 3 of the input and you go to know. That's it. So this is the complete transient analysis that is completed. We have solved a lot of problem. We have seen a lot of circuits. So everything that is necessary for you, whether it is written test, whether it is placements, whether it is gate exam, whether it is ISRO, any tough to toughest exam, there will be no concept that you don't know from transient analysis if you have studied from these lectures. So I guess it is around 30 hours of transient analysis and 20 hours of basics of network. So around 50 hours will be there. So that's enough for gate aspirants. Now you will be studying AC circuits. Okay. For placements, guys, there are allowed few more concepts left. So 10 hours of content will be more. Okay. So 10 hours of concepts will be coming more for placement, guys. Not for gate aspirants. For gate aspirants, you will be studying AC circuits now, and for placements, guys, they will be studying few more concepts. Okay. So yeah, let's meet you in the further lectures. So I hope you have enjoyed the lecture. If you have enjoyed the lecture, please do share it with your friends. Okay. And I am giving my level best here. Okay. And this is uploaded on YouTube as well. So please do share it with your friends. Please tell them that study from this and you will get to understand a lot of things. Also, your interest will be developed. So please do share it with your friends. Okay. So all we need is your support. And if the support is there, I will put my level best to bring best of the best content. Okay. Thank you.